Welcome back. Here's a short VI problem for a capacitor. Okay, we're given V as a function of t for a capacitor given by 30 t squared. So this is over a couple of intervals. 30 t squared volts from 0 to 0.5 seconds. And it's 30 t minus 1 squared volts from 0.5 to 1 second. And then 0 volts everywhere else. And so basically this is the circuit. It's a voltage source that's varying with time by this waveform applied to a capacitor, a 20 microfarad capacitor. So here's the voltage and the current, and so this is all given, and then what we're asked to find is I of t, and sketch it. All right, so we're just going to use I equals CV prime. That's the only thing we need to mess with. It's pretty quick problem. So from 0 to 0.5 seconds, I equals CV prime, and C is 20 microfarads, so 20 times 10 to the minus 6 farads, and then V prime, the derivative of 30t squared for that interval is 60t. So you end up with 1.2t, and this is going to be milliamps. So it's actually point. If you multiply these two numbers together, you're going to get 0.0012 t. So I'm just condensing that, writing it as 1.2 t, and then making the units milliamps. So be careful of your units on this stuff. You know, when you're entering this stuff in your calculator, you have to use base units, right? You use base amps, volts. You don't enter milli on anything on that. And then, but sometimes we'll write down milli, and we'll move the zeros around when we write stuff down, just so we don't have a whole bunch of zeros. But just generally speaking, just be careful of your units. Anyway, for the second interval, we're just going to use, this is the same, the same capacitance, and then the derivative of this thing in here, which is going to be it's going to be 60 t minus 1. So that works out to 1.2 t minus 1, and the units are milliamps. Okay, so there's our two equations, and we could plot those guys. So we're given this voltage. Let's plot that. So V in volts, it looks like this, and then it comes on down to that. If you take the time to plot it, and if you solve this at 0.5, you're going to end up with 7.5 volts. If you plug in 0.5 seconds, so this is t in seconds. So that's given, and then our answer is these two equations. So this is I in milliamps and t in seconds, and it ends up looking like this. And if you solved this at 0.5 seconds, you would end up with 0.6 milliamps, and it drops down to minus 0.6. Okay, so pretty short problem. See, we've got a step change in current, which is okay for a capacitor, but we do not have a step change in voltage, which is what we'd expect from a capacitor. Remember, capacitors cannot step change in voltage, because that would step change in voltage would imply a instantaneous change in the energy that's in this thing, which can't happen. All right, so just a real short little problem, just playing with this I equals CV prime and doing some equations. Pretty short, simple. All right, bye.